Hello Math Analysis students. In this video we are going to go over how to solve the problems from page 1 of the Unit 4 review sheet on conic sections. Quick recap, our three conic sections that we have learned about are circle, ellipse, and hyperbola. There is a fourth conic section that we did not study this year, which is parabola. We did not study it this year because you have studied that already a lot in Algebra 2. Okay, so let's begin going over page 1 of this review sheet. There are 3 problems at the top, and for each of these you are asked to write the equation in standard form. So we want to see if we can figure out what type of conic section it is, and then put it in standard form by completing the square. So for our first problem right here, we should hopefully be able to tell when we look at this that this is the equation of a circle. And we can tell that because it has an x squared and a y squared. They're both the same sign, and they have the same coefficient. So we want to group our terms together. We want to put our x terms together, and we want to put our y terms together, and we want to put our constant on the other side of the equation. So my first step is just going to be to rewrite them. And I'm going to use colors here to keep everything together. We have an x squared minus 10x. I know I'm going to be having to complete the square. I'm going to have to add something right here, so I'm going to go ahead and draw myself a little blank. And then for my y squareds, I have a y squared plus 8y. I'm going to have to complete the square, so we're going to add something, so I'm drawing myself a little blank there. And then I'm going to move my constant over to the other side. And I'm going to have to add something. Whatever I add over here for the x's, I'm going to have to balance that by adding on the right-hand side, and the same thing with the y's. So now let's complete the square once for our x terms, and then again for our y terms. The goal here is to get this into something of the form x minus h squared and y minus k squared. So we want to be able to rewrite this as a perfect square trinomial. So we're going to take half of our middle term. Half of that negative 10 would be negative 5. We square that, we get 25. So we put 25 in this blank here. But whatever we do to one side of the equation, we have to do to the other. So if we added 25 on the left, then we have to add 25 on the right. We'll complete the square for our y terms. Half of our y term, that's 8. Half of that is 4. 4 squared is 16. So we added 16 on the left, then we have to add 16 on the right. Now we rewrite these as perfect square trinomials. X squared minus 10x plus 25 is equal to the quantity x minus 5 squared, and that minus 5 coming from the half of the negative 10. And this y squared plus 8y plus 16 is the quantity y plus 4 squared. And then on the right, when we add these up, 8 and 25 and 16, then we get 49. This is the equation for our circle. The circle has a center at 5, negative 4, and a radius of 7. Now let's move on to problem 2. For number 2, this one is a different type of equation. We can see that we have an x squared term and a y squared term, and one is positive, the other is negative. This is telling us that it's a hyperbola. We still want to group our x's together, and we want to group our y's together. And we want to put our constant over on the other side. So my first step is I'm just going to regroup. So 4x squared plus 32x, and then minus y squared plus 6y. And on the other side, when we move this 39 over the other side, it's going to become a negative 39. Okay, now to complete the square, this time is a little bit different from the last one with circles, because these have coefficients. So for our x, we need to factor out the greatest common factor for the numerical parts. We need to factor out 4. When we take that out, we're going to have x squared plus 8x. And then we're going to need to complete the square, so we're going to need to put in something else right there. For our y's, we need to factor out a negative 1. Be careful, students. Students have trouble with this sometimes. You got to factor out the negative 1. And that's going to leave us with a y squared minus 6y. And we're going to have to add something else there, so I'm going to leave a blank. And over on this side, we have negative 39. I'm going to have to add something. Whatever I put on the left for my x's, I need to put on the right. And whatever I put for the y's, I also have to balance it on the right. So, for the x's, I'm going to come over here. Sorry, I got a little ahead of myself there. Sorry, I want to take half of this 8, which is going to be 4, and square that, which is 16. So we put 16 into our blank right here. So we have to add a corresponding amount on the other side. But we didn't really just add 16 here because of this 4 outside. This is really 4 being distributed, so it's 4 times 16. We've really added 64 on the left-hand side, so we need to add 64 on the right-hand side. Repeat the process with the y's. Half of our -6 would be a -3, and 3 squared is 9. But consider what's being distributed. This is a -1 times 9, so we really just put a -9 on the left, so we need a -9 on the right. Now, let's rewrite as perfect square trinomials. On the for the x's, we have 4, and this is going to give us x plus 4 squared, because that x squared plus 8x plus 16 is equal to the quantity x plus 4 squared. And then we have -1. And this y squared minus 6y plus 9 is y minus 3 squared. And on the right-hand side, when we add up these terms, then we're going to get -9. Excuse me, 9. Sorry, I cannot add very well. I apologize. On the right-hand side, we're actually going to get 16. So ignore my 9s. Sorry, I was looking at the wrong thing. Okay, so now we have completed the square. We need to get it into the right form for a hyperbola. We need to have something underneath our x terms and our y terms, and this right-hand side needs to be 1. So we want to divide by this constant over here on the right. We're going to divide by 16. So we'll divide the right by 16 and divide the left by 16. When we divide the left by 16, I'm going to go ahead and split it up here as my x's and my y's. And then we want to simplify our fractions any if we can. For these x's, we've got 4 over 16, which is 1/4. So this becomes x plus 4 quantity squared over 4 minus, now we don't have to write the 1 right here. This is going to be y minus 3 quantity squared over 16, because we don't need to change anything here. And then equals 1. And there we go. That is our hyperbola. If we needed more information, we could tell that this would have a center at -4, +3. Because the x comes first, it would open horizontally left and right. Okay, let's move on to number 3. This is the equation of ellipse. We can tell because we have an x squared and a y squared. They're both positive, but they have different coefficients. So we want to do as we've been doing before. We want to get our x's together. We want to get our y's together. We want to move our constant over to the other side. So 4x squared plus 40x. And then y squared plus 6y. And then on the other side, when we move the -35 over, then it becomes a +35. Okay, for our x's, we need to factor out this 4. That's going to give us an x squared plus 10x, and then we're going to add something else to it right there. And then for our y's, we're going to need to add something else to this as well. And on our right-hand side, we will have our 35, and we have to add whatever we add for the x's and whatever we add for the y's. So for our x's, we're going to take half of this 10, which is 5. 5 squared is 25. That goes in this blank right here. But don't forget about this 4 out front. This is really 4 times 25, so we've really added 100 to the left-hand side. So we need to add 100 to the right-hand side. For our y's, half of this 6 is 3. 3 squared is 9. So we added 9 to the left-hand side. There is nothing out front parentheses, so we don't need to do anything else except for add 9 to the right-hand side. Let's rewrite. This is 4, and this x squared plus 10x plus 25 is equal to the quantity x plus 5 squared. And then this y squared plus 6y plus 9 is equal to the quantity y plus 3 squared. And when we add up the numbers on our right-hand side, then we get 144. We've completed the square. Now we need to make it look like the right form. We need numbers underneath our x and our y, and we need our right-hand side to equal 1. So we're going to divide by this constant, which is 144. Divide the x term by that, divide the y term by that, and we divided our right-hand side. And when we simplify, then we get, this will be x plus 5 squared over 36. For the y's, nothing needs to be changed. This is y plus 3 squared over 144. And on the right-hand side, equals 1. And that's our equation for an ellipse. We can tell the center would be -5, -3, and this would be a vertical ellipse because the bigger number is underneath the y term. Excuse me. Moving on to our next section, we're supposed to identify the conic as a circle, ellipse, or hyperbola. Look for the squared terms. Excuse me. Look for the signs of the squared terms, and then look at the coefficients of those squared terms. For number 5, we can see for number 5 that we do have two squared terms, an x squared and a y squared. They're both the same sign, and they have different coefficients, which makes this an ellipse. For number 6, we have an x squared and a y squared. They're the same sign, and they have the same coefficient, which makes this a circle. For number 7, we have an x squared and a y squared, but they are different signs. See how this one is negative and this is positive? That makes this one a hyperbola. And for number 8, we have an x squared and a y squared, but again, they are different signs, which makes this a hyperbola. For these problems, you really shouldn't be doing any math. These should be just recognition based on the squared terms and their signs and their coefficients. And that's page 1. Good luck.